This is lecture 12. I'd like you to start by going to your lecture outline and under tubular reabsorption, notice the point where it says sodium and water reabsorption. And you'll see here you're being directed to page 788, figure 20.21. So let's take a look at that figure. Notice first of all in the upper left-hand corner the indication that the portion of the tubule that's enlarged down below is the proximal tubule. And so the major enlarged lower part of the figure now, the tubule that we're seeing is again the proximal tubule. And let's just follow the steps. And this is a very basic figure. It's fairly easy to go through. So notice first of all then, we have glomerular filtrate beginning to make its way through the proximal tubule. And of course, close by is a branch of the peritubular capillary system up above. And if we just follow stepwise then, the numbers as blood is moving through the capillary and as filtrate is moving through the proximal tubule nearby. And number one then, sodium ions are being reabsorbed by active transport. And notice then the arrow showing that reabsorption. And of course reabsorption again from the proximal tubule in this case, and reabsorption always into a capillary. As we go more toward the right now, as blood is flowing along from left to right, as filtrate is flowing along from left to right, notice number two, bicarbonate ion, HCO3, is also being reabsorbed. And there's a note that this bicarbonate reabsorption is linked to sodium reabsorption. So sodium is reabsorbed, and then correspondingly bicarbonate is also reabsorbed. As we move along in both the capillary and the tubule, think about what's happening. Now we have chemical substances moving from the tubule into the capillary. And this, if you think about it, is making the fluid in the capillary hypertonic to the fluid in the tubule. Hypertonic, again, remember, containing more dissolved chemicals. And again, then, as these chemical molecules move into the capillary becomes hypertonic. Correspondingly, the contents of the tubule become hypotonic. And number three, again, then, as a result, water moves from the hypotonic area to the hypertonic area. Water moves from the tubule into the capillary. And I'll give everyone a minute to just make sure you're good with that and to jot down what you need to up to this point in your notes. So 1, 2, and 3, sodium, number one, absorbed by active transport. Again, make sure you have time to find that being shown. Number two then, bicarbonate absorption linked to occurring when sodium ion reabsorption occurs. Number three, as we move along, as these chemicals, sodium and bicarbonate, as these chemical molecules move into the capillary, the plasma becomes hypertonic, the filtrate becomes hypotonic, water moves by osmosis from the tubule into the capillary. And then finally, number 4, now notice we have chloride ions being reabsorbed and just realize one reason for this is the high concentration of sodium in the capillary. So we're collecting a whole bunch of sodium in the capillary. Sodium ions, remember, positive charge. And as a result, chloride ions with their negative charge are attracted, and chloride leaves the tubule and is attracted by those positive sodium ions in the capillary. Back to your outline, and notice now where we have right under tubular secretion, which we talked about last time, where we have regulation of urine concentration and volume. I've crossed that out, so we're not going to get into that. And so correspondingly then, under that topic, you can also cross out the countercurrent mechanism. And we're going then, notice, to urea and uric acid excretion. And so let's flip over now in your textbook to page 792. First topic, lower left, urea and uric acid excretion. And here I'd simply like you to know what urea is and what uric acid is. And notice then, if you're reading just underneath urea and uric acid excretion, the term urea is bolded. And specifically then, you should know that urea is produced by breakdown of amino acids in the liver. That term catabolism that you're seeing, remember, implies chemical breakdown. And so again, urine is produced by the breakdown of amino acids in the liver. And going down to uric acid, and you're seeing here that uric acid is produced by the metabolism of some nucleic acid bases. Take a minute then, think back to ANP1, and recall that nucleic acids, DNA and RNA, and this doesn't all have to go into your notes, but just recall that DNA and RNA are made of nucleotides, and each nucleotide consists of 3 different parts, and one of those parts is an acid, a nucleic acid base. And you'll recall then those letters A and T and C and G. So the A's and the T's and the C's and the G's, remember, are these bases that make up nucleotides, that are found in nucleotides. And now we're simply saying that the breakdown of a couple of these, and I don't care that you remember which ones, but a couple of these, A's and T's and C's and G's, when they're chemically broken down, produce uric acid. Let's go next to this idea of renal clearance, also on page 792. And here I'll direct you, and I'd like you to be familiar with just the information in the first two sentences. And I'll give you just a moment to jot down that information or make a note to be familiar with those two sentences. So I'll be back in just a minute after you've had a chance to copy those two sentences or to make a note of what's in those two sentences. And so renal clearance then, the rate at which a chemical is removed from the plasma, and then the second sentence, renal clearance tests are used to detect or monitor renal disease. And I would like to stop right there on that part, the renal clearance information, without going into some of the specifics that I'd talk about if we had a bit more time and if we were face to face. Let's conclude lecture 12 right here. We'll be back with probably a fairly short lecture 13, and that will take us to the end of the chapter.